So in our last example here, we're given various angles and we have to find the arc sine of their sine, or the same kind of thing for cosine and tangent. So it's very important that you be able to graph these on a unit circle. That's really the way you start a problem like this. So there's my unit circle. And that's 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, negative 7 pi over 6, the negative means you go in the downward direction from 0. You go a little bit past pi, and negative 7 pi over 6 puts you right there, negative 7 pi over 6. So, arc sine of negative pi over 6, or negative 7 pi over 6. Well, the sine of that angle is the y-coordinate, and it's positive there, so it's arc sine, and that's a 30, 60, 90 triangle. So I know the common values there are 1/2. It is positive because the y-coordinate's positive. So it's arc sine of 1/2. But remember that arc sine is always between negative pi over 2 and pi over 2. So I want an angle between negative pi over 2 and pi over 2 whose sine is 1/2. Well, sine is the y-coordinate. So there's an angle whose y-coordinate is 1/2, and that angle is pi over 6. So my answer there is pi over 6. It's an angle between negative pi over 2 and pi over 2 whose sine is 1/2. Let's try the next one. Arc cosine of 4 pi over 3. Well, I find 4 pi over 3, that's between pi and 2 pi. In fact, that's down here. Its cosine is its x-coordinate. So its cosine is its x-coordinate, and there, again, we have a 30, 60, 90 triangle. So its cosine of 4 pi over 3 is 1/2, but since we're on the left side of the page, it's negative because the x-coordinate is negative there. And now I'm trying to find the arc cosine of negative 1/2. Remember, arc cosine, you always look for an angle between 0 and pi. So I'm looking for an angle between 0 and pi whose cosine is negative 1/2. And there it is right there. That's 2 pi over 3. It's between 0 and pi, and its cosine is negative 1/2. So our answer there is 2 pi over 3. Finally, we have the arctangent of the tangent of negative 5 pi over 4. So let's figure out where that angle is on the unit circle. It's negative, so we're going around in the downward direction from 0. 5 pi over 4 is just past pi. So we go down in the downward direction and we end up over here at 5 pi over 4. So negative 5 pi over 4, sorry, that's negative 5 pi over 4. Let me label that carefully. Negative 5 pi over 4, its tangent, well, its tangent is its sine over cosine, and that's a 45, 45, 90 triangle. So its tangent, it's sine over cosine. A sine is root 2 over 2 because it's positive. Its cosine is negative root 2 over 2. That simplifies down to -1, so we want the arctangent of -1. Now, arctangent always takes values between -pi/2 and pi/2. So arctangent, we're looking for an angle between -pi/2 and pi/2 whose tangent is -1. So I'm looking for an angle whose tangent is -1, and there it is at that 45, 45, 90 triangle. There's my angle whose tangent is -1, and that angle is -pi/4. So to recap what really made it possible to do this problem, we were finding sines and cosines and tangents to start with. So the first thing you need to know is your common values of sine, cosine, and tangent. You need to be able to graph these things on the unit circle. You need to be able to identify the 30, 60, 90 triangles and the 45, 45, 90 triangles and know the common values. Remember, the common values for the 30, 60, 90 triangles are always 1/2 and √3/2. The common values for 45, 90 triangles are √2/2 and √2/2. So you need to be able to you need to know those common values and identify which triangle you're working with, and then figure out which quadrant you're in to figure out whether the sine and cosine are positive or negative. And the way you remember that is by all students take calculus. In the first quadrant, they're all positive. In the second quadrant, sine is positive only. In the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. So you figure out which quadrant all these things are positive or negative, and so then you can find your sine and cosine. And then what we had to do was find arcsines and arccosines and arctangents. And the key to that was, again, remembering the common values, but also remembering these ranges. Arcsine has to be between -pi/2 and pi/2. Arccosine between 0 and pi. And arctangent between -pi/2 and pi/2. So what we were doing at this step for all three problems was we had the sine or the cosine or the tangent, and we were trying to find an angle in the appropriate range that had the correct sine or cosine or tangent. That's what arccosine, arcsine, and arctangent are. You're looking for an angle whose sine, cosine, or tangent is the value that you're given. So, and you're looking for an angle inside this range. So in each case, we had a value, and we found angles inside that range that had the right sine, cosine, or tangent. So that's what the answers are. So that's the end of our lecture on computations of inverse trigonometric functions. These are the trigonometry lectures for educator.com.